Hello and welcome to my new video. My name is Thomas and I like to code. My wife and I were going grocery shopping once a week, so we need to plan all our meals in advance. This is a very time consuming and sometimes tedious task, so I wanted to build something that helps us speed up the process a bit. So I came up with the idea of a meal suggester. It does exactly what it says, it suggests meals. Do you know what you're going to eat for the rest of the week? Me neither. Let this one decide. I'm going to split this project into two parts, the front end and the back end. This video is all about the back end, so I'm going to explain how to connect to a database and write a REST service. Gosh, this is hard. I'm going to split this project into two parts, the front end and the back end. This video is all about the backend, so if you want to learn how to write a REST service and connect to a database, then stick with it. Okay guys, so let's get coding. After the first coding session is done, let me quickly show you what I've done so far. Since I'm writing the backend, I put all the code in the backend directory. The frontend code will be right next to it, but for now, this is a future Thomas problem. Let me first explain the folder structure I usually use for my REST services. For each REST resource, I'm going to have one golang package. So for instance, I will have a /meals endpoint, and therefore I created a meals directory which contains all the meals code. There will also be a /suggestions endpoint, but since I'm lazy I put the code into the same directory. And it's only one endpoint, so come on guys, cut me some slack. Now let's have a look at the content of the meals folder. First there's the model_scope file. This contains the struct that gets encoded and decoded to JSON while communicating with the server. Again, since I'm very lazy, I use the same struct to store it in a database. But I think it's justifiable because the struct is so simple. Each meal has only one ID, a name and a category. Next we have the handler file. This contains all the HTTP handler functions that will be used from the server to answer the requests from the user. One thing I like to point out is the meal handler has a pointer to a meal service field. This will become important later on, so keep it in mind. Other than that, nothing new here. Each of these handler functions serves one single REST request. So for example, if the user calls the /meals endpoint with the get method, the list_meals function will be called. The sendError function is simply a helper function I use to, send errors. I wrap the error message into a response body, then set the correct content type as well as the status code. And with the write function of the response writer, I send the error right back to the user. Every single one of these handler functions is built the same way, so I will not go over every single one of them. But let's have a closer look at the list_meals function to get a better understanding of what is happening here. First, I always prepare whatever URL parameter or request body is sent from the user. Then I use them as arguments and simply pass them to the meal service. After that I encode whatever the meal service returned, set the right headers and off it goes to the sender. Pretty standard handler function stuff. The last and most interesting file we need to talk about is the service file. This is where the magic happens. A good practice that I picked up from a senior colleague when I was just a greenhorn is to use simple arrays or maps as your database while coding your service. This serves two purposes. First, you can test your HTTP stuff without worrying about the database connection. And second, if you do it right, you automatically end up with a good code architecture. Since you want to remove the in-memory code and replace it with a real database, you are forced to keep your database code at one place. If you need to touch more than two files while swapping databases, you did it wrong. So if you're not doing this, give it a try and thank me with a like. I will not go over this code since I'm going to throw it away anyways. The only interesting thing is the init function where I filled the meal slice with some random meals I picked up from the holy mother of all meals, the internet. Lastly, let's have a look at the main function. This is where it all comes together. To actually serve my HTTP functions, I'm using the Gorilla Mux library. Even though there are a lot of other libraries out there, I kind of like this library the best. But it's totally up to you. You can even use the Golang standard library if you want to. But let's go over the code now, since this is what you came for, right? First, I define the default port and create an instance of the meal service and the meal handler. Then I create a new router. The useEncodedPath function is needed to encode the URL variables like the ID here in the delete URL. Then I create a subrouter for the meals endpoint and register all the handler functions to their corresponding paths and REST methods. Like for instance, the get method on the /meals path will be served from the meals handler list_meals functions. Same goes for the post method on the meals path and the create meals function. Later on I create another subrouter for the suggestions endpoint and register the corresponding handler function. Then I create the HTTP server passing in the created router as the handler, the port as the address and a 10-second read timeout. This might seem a little high, but I had some problems with my older Raspberry Pi if I set it to a smaller number like for instance 2 seconds. and in the end I start the engine. To check if the backend code is working, I'm using good old curl. So let's start the server, create a new terminal window, and let's see if I can list the meals. Okay, I got a response. Let me quickly pipe this to JQ. For those of you who don't know JQ, this is a CLI to process JSON data. Right now I simply use it to prettify the server response. I'll leave a link in the description below if you want to learn more about it. Definitely check it out if you don't know it. But for my response, as you can see, I got 8 meals. Now let's try to filter them by category and only show the low carb meals. Yep, this will work. I forgot to quote the URL. Now this looks better. Only 6 meals this time. The meal with the ID 1 and with the ID 8 are missing. Looks good. Let's quickly check if I can retrieve them by filtering for fast food meals. Okay, so this works. Next on the list is creating a new meal. I'm thinking burger. Let me put this into the low carb category. I will show you in a minute why. The server responds with a new ID. Let's quickly check if this has really been added to the list meals. Okay, there you go. I intentionally put the burger into the wrong category so I can show you that the put command is working. With the put command you can edit meals. So let's change the category to fast food, shall we? And there you go. The burger is now in the correct category, right where it belongs. Oh shoot, I forgot that I actually hate burgers. So let's remove them from our meals. Delete meal number 9. And there you go, no more burgers for me. Now that we saw that the server is actually working, I'm going to remove this in-memory database and replace it with the best database in the world, the file. Just kidding. Or am I? I will be using a SQLite database. This is a very lightweight database that actually stores the data into a file, but for my purpose that's totally okay. I'm done replacing the in-memory database with the SQLite database. I left in the old code so I can show you a cool trick that I picked up years ago while learning Golang. If you take a look at the files, you see that I added a service types file as well as the service memory and a service SQLite file. The service types file contains the interface that I will be implementing in the two respective files. If you look at the handler, you can see that it now takes an interface as an argument, so I can pass different implementations of my interface to the handler. I will show you why this is important in a sec. The service memory file contains all the old code using the meal slice. And the service SQLite file contains the implementation of the service interface that will store the meals in a SQLite database. Now let's see why this is so cool. If you look at the main file, you can see that I have two implementations of the meal service. At the moment my application still uses the in-memory service. To use my new service with the SQLite database, all I have to do is to swap these and the code will work. So remember kids, always use protection and interfaces. Now let's see what happens if I start the server. As you can see, I have a new file called mealsdb that just popped up. Further down in the main file, I also created the meals table if it doesn't exist. The SQL statement is pretty straightforward. Let us now check out the SQL meal service code. In contrast to the in-memory implementation, the SQL meal service receives a database handle called db that gets created in the main file. Using this, I can perform all my database operations. Now let us go over all the functions. The list meals function queries for meals depending on whether or not a category was provided. If it was, the query will contain the where clause. After that, I iterate over the returned rows, create a meal instance and append it to the meal slice. And in the end, I return all the found meals. The next function is the create meal function. First, I prepare the statement and then I execute it using the variables from the meal argument m. Since the ID of the meal is an auto-incremented integer, I do not have to worry about setting it myself. The last inserted ID is returned to the handler function and will be returned to the user within the JSON response as well. The delete function takes the ID as an argument and executes the prepared delete statement. If no meal has been deleted, hence if no row has been affected, I return an error. The next function is the added meal function. This sets the name as well as the category fields for the meal with a given ID. Again, if no meal has been updated, I return an error. Lastly, the suggests meal function works quite similar to the list meals function. I retrieve the rows using the where category equals clause, iterate over them, create a meal instance and append it to the meal slice. The only difference is in the SQL query. This time I used a random function which returns a random row and a limit clause to only return a specific number of rows. One word of caution though, if you use the random function on a large table, the query might become very slow, but in my use case it's totally fine. So now, after using the SQLite database, let's see if the backend is still working and get some curls running. So let's list all the meals. Okay, this seems to work. Perfect. So since the meals list is empty, let's add some burgers. Let's check the meals again, and there we go, we have our burger. Now let's go over all the other meals and simply add them to the SQLite database. Now that this is done, let's see if we have all our meals on our list. Okay, looks good. So the create meals functionality is still working. Next, let's see if we can only retrieve the fast food ones. Okay, this looks good. Next on the list is the edit functionality. Let's see if we can change the last one. Okay, let's make it a tuna pizza and hit enter. Retrieve the meals again and we have our tuna pizza. Looks good. Now let's remove this and here we go. We only have 8 meals left. So the delete functionality is working great. The last thing we need to check is the suggestions endpoint. Let's see what happens if we query /suggestions. So the database provides us with 5 random meals. If we query again, we can see that we get different meals. So this seems to work. Now let's see if we can retrieve only the low carb meals. So now we only have 5 low carb meals and 5 different ones. Seems to work. The last thing we need to check is the count parameter. If we type in count equals 2, we only get 2. So the backend is working. Now the server is running, the database looks good. The only thing that's left to do is deploy it on this one. Stop! Deployment time! Ding, 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 ding. As you can see on the screen, on the right side, I'm already connected to my Raspberry Pi. I'm already in the projects folder where the application will be deployed to. As you can see, it's empty for now. So let's create the mealsuggester directory. Okay, here we go. The next thing I need to do is to build the application. Since I'm deploying to my Raspberry Pi, I need a Linux operating system and the ARM architecture. The rest of the build command is pretty straightforward. Okay, here we go. After the application has been built, I need to copy it to my Raspberry Pi. I'm doing this with the secure copy command. Just copy the executable right into the directory where it belongs. Okay. As you can see, the executable has been copied and is now in the mealsuggester folder. So now let's give it a try. Well, what is this? Okay, I need to do some digging. Well, stuff like this happens all the time, so we need to find a solution for that. After some Google action, I found out that this is actually the problem. The library that I'm using requires cgo. Cgo is used to talk to C code within Golang, and I suppose that since SQLite is written in C, I think this library needs the compiler to actually work. After some searching, I found another library that doesn't require cgo, so I hope this will work. It's also supposed to work for Linux and an ARM architecture, which is what I use for my building process. So I suppose we can give this library a try. We need to make some minor changes, and here we go. Unknown driver, what is this? Let me quickly check. Ah, okay, here we go. I need to change this here, fire it up, and okay, this looks good. Now, build it again, copy it again, go back to my Raspberry Pi, and the server is running. Great. Now that the backend is fully functional on my Raspberry Pi, the only thing that's left to do is to write the front end. I'm going to do this in the next video, so stay tuned. Thanks for watching. If you like this video, you know what to do. Until next time, keep on coding.